From the dawn of humanity, we've gazed up at the stars and wondered, where did we come from? Are we alone? What is our place in this vast universe? This curiosity is deeply embedded in our DNA. It drives us to explore, to question, to understand. For centuries, our understanding of the cosmos was limited by what we could see with our naked eyes. Then came telescopes, extending our vision and revealing wonders beyond imagination. We discovered new planets, distant galaxies, and the expanding fabric of space-time itself. The more we learn, the more we realize how much we don't know. The universe is full of mysteries, challenging our assumptions and pushing the boundaries of our knowledge. Just when we think we have a grasp on things, a new discovery forces us to reevaluate our place in the grand scheme of existence. One such discovery has sent shockwaves through the scientific community, forcing us to confront a mind-boggling possibility. What if our universe isn't what we think it is? What if it's all a sophisticated simulation? The James Webb Space Telescope, our most powerful eye on the cosmos, has peered deeper into the universe than ever before. It has captured light from the earliest stars and galaxies, offering glimpses of the universe's infancy. But amidst these groundbreaking observations, something unexpected emerged. JWST detected patterns, anomalies in the structure of space-time itself, that don't fit with our current understanding of the universe. Imagine looking at a seemingly smooth surface, only to discover upon closer inspection a hidden grid of pixels. These anomalies suggest that the fabric of our reality might be pixelated, quantized at an incredibly small scale. This discovery has reignited an age-old debate. Are we living in a simulation? While the idea may seem like science fiction, it's a question that philosophers and physicists have grappled with for centuries. Now, with the JWST's findings, the line between science fiction and scientific possibility has blurred. This discovery doesn't offer definitive proof of a simulated universe. However, it's a tantalizing piece of the puzzle, forcing us to confront the limits of our knowledge and the very nature of reality itself. The simulation hypothesis proposes that our reality is a sophisticated computer program, created by a more advanced civilization. Think of it like a high-tech version of the Matrix, but instead of being plugged into machines, our entire universe is the simulation. This idea isn't new. Philosophers have pondered the nature of reality for millennia. However, it gained significant traction in 2003 when philosopher Nick Bostrom published his seminal paper, Are You Living in a Computer Simulation? Bostrom argued that if advanced civilizations are possible, and if they have the capability to create realistic simulations, then it's statistically probable that we are living in one. This idea has captured the imagination of many, including tech entrepreneurs like Elon Musk, who believe it's more likely than not that our reality is simulated. But how do we reconcile this mind-bending concept with our everyday experiences? We can't see the code, feel the glitches, or escape the simulation, or can we? The limits of science, can we ever truly know? The simulation hypothesis presents a fundamental challenge to the scientific method. Science relies on observation, experimentation, and the search for patterns to understand the universe. But what if the very laws of physics that govern our universe are simply lines of code in a giant cosmic computer program? If we are living in a simulation, our ability to discern the true nature of reality might be fundamentally limited. It's like trying to understand the inner workings of a computer by simply playing a video game on its screen. We can observe the rules of the game, but we can't access the underlying code. This raises profound questions about the limits of human knowledge. If our reality is a simulation, can we ever truly know the nature of the real universe outside the simulation? Or are we forever trapped within the confines of our digital prison? Glitches in the matrix, evidence or imagination? Proponents of the simulation hypothesis often point to certain phenomena as potential evidence for our simulated existence. These glitches in the matrix range from the strange world of quantum mechanics to the apparent fine-tuning of the universe's physical constants. For instance, the bizarre behavior of particles at the quantum level, where they can exist in multiple states simultaneously, could be interpreted as evidence of a simulated reality running on limited processing power. Similarly, the precise values of physical constants like the speed of light or the gravitational constant, which seem perfectly calibrated for life to exist, could be seen as evidence of a designed simulation. However, these interpretations are highly speculative. While these phenomena remain mysterious, they can also be explained by our evolving understanding of physics and cosmology. Attributing them to a simulated universe requires a leap of faith. going beyond the available scientific evidence. Debunking the simulation arguments from physics and beyond. While the simulation hypothesis is a captivating thought experiment, it faces significant challenges from both scientific and philosophical perspectives. Critics argue that it's untestable and unfalsifiable, making it more of a philosophical musing than a scientific theory. From a physics standpoint, the simulation hypothesis struggles to explain fundamental aspects of our universe, like the arrow of time or the origin of consciousness. Moreover, creating a simulation as complex as our universe would require unimaginable computational power, far beyond anything we can currently conceive. Philosophically, the simulation hypothesis raises more questions than it answers. If our universe is a simulation, who are the simulators? What is their purpose? And what does it even mean for something to be real in a simulated world? These questions highlight the slippery slope of the simulation hypothesis. It can lead to an infinite regress of simulations within simulations, ultimately offering no satisfying answers about the nature of reality. The unending quest for knowledge in a simulated world or otherwise. The debate surrounding the simulation hypothesis, while unlikely to be resolved anytime soon, underscores a fundamental truth about our existence. We are driven by a deep-seated desire to understand the universe and our place within it. Whether we live in a simulated reality or a real one is ultimately beside the point. The pursuit of knowledge, the questioning of our assumptions, and the exploration of the unknown are what define us as intelligent beings. The JWST's discovery, regardless of its implications for the simulation hypothesis, serves as a powerful reminder of the vastness and mystery of the cosmos. It fuels our curiosity, inspires new questions, and pushes us to expand the boundaries of human understanding. So let us continue to explore, to question, and to marvel at the wonders of the universe, simulated or otherwise. For in the pursuit of knowledge we find our greatest purpose and our most profound connection to the cosmos.